Now, fission, F-I-S-S-I-O-N, fission is a chain reaction. Is it a chain reaction? Now, fusion, it seems, is not a chain reaction. Fusion is a brute force method. You either do or you don't. Maybe we have to use a chain reaction for fusion as well. Chain reaction fusion. Now, it's incredible that it's much easier to split a heavy atom than to combine two light atoms. Now, let's talk about flow charts. The hydrogen isotopes, hydrogen being theoretically the simplest atom. The flow chart of the formation of hydrogen. Source being a black hole that eventually decays down to hydrogen gas. Now the isotopes of hydrogen. Draw a flow chart of how hydrogen isotopes are formed. If you have a hydrogen atom, how do you get a deuterium? How do you get the tritium? What are the half-lives? Now do the same for helium. Now the half-lives that we have are for the conditions on Earth, not the conditions on the Sun. The half-life on a different area of the universe may be different. Like the gravity on Mars is different from the gravity on Earth. The gravity on the Sun is almost 30 times that of the gravity of the Earth. So now it seems, to break plutonium down, which is fission, you had to hit it with neutrons. You had to try to give it more neutrons, and then it tried to stabilize itself. And in so doing, it released that much amount of energy and that much amount of radiation. Now, fusion maybe fusion works this way that I'm going to say. Maybe the unstable isotopes, need to be encouraged in one direction or the other. Suppose you encourage the tritium into the helium direction, the tritium isotope into the helium direction, and the helium unstable isotope into the hydrogen direction. What will happen? And how can you do that? Now, in addition to the mass of the nucleus, what will overcome the charge of the nucleus? Electrons. It seems that electrons are the magic things in these cases. If you have a electronegative atom, quasi-atom, it will attract a proton, right? If you have an electronegative helium, ion, let's say, it has to, if it's electronegative, it's an ion. Ionized helium, well, because it has to be ionized, that's why it needed to be in plasma, I guess. Is that why? Or nobody knows? Or nobody cares? They just want to report progress or report salaries, right?